Texan Global School. Special lines and points in triangles. Triangles have lines that can form intersection points, which are discussed in this class. Lines include the median, perpendicular bisector, angle bisector, and altitude or height. The median is a line segment that is originated at the vertex of a triangle towards the midpoint of its opposite side. Let's see an example. Given an equilateral triangle, we will construct one of its three medians. Based on the definition, the median starts at one of the vertices of the triangle. We select the upper vertex. And since the line must reach the midpoint of the opposite side, which is nothing more than the point that divides one side into two equal parts, we join the points, thus obtaining the median. We will repeat the process, but now with this other isosceles triangle. Select another vertex and identify the midpoint of its opposite side. And by joining the 2 points, we get the median. In this other example, we will construct the median of the following scalene triangle. Select the upper vertex and identify the midpoint to its opposite side. And so, draw a line from the vertex towards the midpoint, called the median. Now, if we draw the 3 medians of any triangle, we will construct an intersection point called the barycenter, also called the centroid or center of mass. Using the first example, we will draw the 3 medians from each of the vertices of the triangle to the midpoints of its opposite sides. The intersection of the 3 medians is the centroid. This point of the triangle is 2/3 of the way from the vertex to the midpoint of the sides. This means that, in this case, at any median, the distance from the vertex to the centroid is twice the distance from the centroid to the midpoint. The perpendicular bisector is a perpendicular line to a side of a triangle passing through its midpoint. Given an equilateral triangle, we will construct one of its perpendicular bisectors. Based on the definition, the bisector is a perpendicular line to the midpoint of one side of the triangle. This means that the side and perpendicular bisector must form a right or 90-degree angle. Thus, we can see the perpendicular bisector drawn. A suggestion to draw perpendicular lines is to use triangular scales or rulers. They are placed perpendicularly, and the line is drawn. We will repeat the process, but now with this other isosceles triangle. Select another side and identify the midpoint. Then, draw the bisector perpendicularly. In this other example, we will construct the bisector of the following scalene triangle. Select the side and identify the midpoint. Then, draw the bisector perpendicularly. Now, drawing the 3 perpendicular bisectors of any triangle results in an intersection point called circumcenter. Using the first example, we will construct the 3 bisectors starting from each of the sides of the triangle at their midpoints. The intersection of the 3 bisectors is the circumcenter. Specifically, the circumcenter is the center of a circumscribed circle of the triangle, as shown. The angle bisector is a line segment that originates at the vertex of an angle and divides the angle into 2 equals. Given an equilateral triangle, we will construct one of its 3 bisectors. Based on the definition, the bisector starts at the vertex and divides the angle into 2 equal ones. Selecting the upper vertex, we know that an equilateral triangle has equal angles. Each measures 60 degrees. Therefore, the bisector will cut the angle in 2 of 30 degrees. You can use the protractor to measure the angle and draw the bisector at half the angle. Using a compass, we first place the compass at the vertex as the center of the circle or an arc so that it touches 2 sides of the triangle. At each intersection, reposition the compass and draw an intersection generating a point. With this point and the vertex, the bisector can be drawn. We will repeat the process, but now with this other isosceles triangle. Select another vertex and measure the angle to draw the bisector by cutting the angle into 2 equals. In this case, the angle alpha represents the value of the angle halved. In this other scalene triangle, select the top vertex and draw the bisector in such a way that it cuts the angle in 2 equals. The beta angle represents the value of the angle divided in 2. On the other hand, the intersection of the three bisectors is the incenter. Using the first example, we will construct the three angle bisectors starting from each of the vertices of the triangle. We can see that the intersection of the three bisectors occurs at the point called incenter. The incenter is the center of a circle inscribed in the triangle, as shown. Finally, the altitude or height is a line segment originated at the vertex of a triangle and is perpendicular to the opposite side. Given an equilateral triangle, we will construct one of its three heights. Based on the definition, the altitude starts at the vertex and is perpendicular to the opposite side of the triangle. Thus, we can see the plotted height. Likewise, we suggest the use of triangular scales or rulers to draw the perpendicular line with a 90-degree angle. We will repeat the process, but now with this other isosceles triangle. Select another vertex and identify the opposite side, in order to draw the altitude perpendicularly. In this other example, we will construct the height of the following scalene triangle. Select the vertex, in this case, the upper one, and identify the opposite side. Extend the opposite side, and draw the altitude perpendicularly. It should be noted that, in this case, the altitude is outside the triangle. Now, drawing the three altitudes of any triangle results in an intersection point called the orthocenter. Using the first example, we will draw the three altitudes from each of the vertices to their opposite sides. The intersection of the three altitudes is the orthocenter. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com